Hi everybody, my name is Schroeder Witt and I'm a postdoc at the University of Oxford. I'm super excited to talk a little bit about open problems and multi-agent security ahead of the Apart Research Hackathon. So what I'm going to do now is I'm going to talk a little bit about what multi-agent security is and give you an overview of exciting problems and exciting recent research that has been happening, and then I'm going to talk a little bit about the specific focus areas of this hackathon. So stand by. Let's start with what is security. So here is a definition from Wikipedia. So security is protection from or resilience against potential harm or other unwanted coercion caused by others by restraining the freedom of others to act. So here's an important distinction between security and safety, right? Safety, particularly in the eye safety context, is more about protection from harm, but not necessarily just harm that is caused by an other. So in security, we usually worry about worst case harm that can be caused by a malicious other. And that's sort of the difference in scope. And multi-agent security, which we'll come to in a moment, in many ways, we can see as a particular sub-area of multi-agent safety. Now, it's maybe most intuitive to consider the security concept through the lens of human cooperation, right? So humans basically require security in order to cooperate, not just humans, but also institutions, nations. And in fact, if there is not enough security, then there is not the trust and confidence that we need in order to have the sort of stability and predictability that allows us to enter long-term commitments. And in fact, if this is the case, then we might still cooperate, right? But this sort of cooperation is more based on extortion or coercion, and in any case, it's not the sort of free cooperation that we actually prefer. So in many ways, security is the foundation of human cooperation. Now we can think a little bit about how security is actually implemented or how it arises in human societies. Here's one suggestion. So this is actually game theoretic. You might know this. This is the iterated prisoner's dilemma. Actually, you only see one iteration. But the idea is that maybe there are incentives in certain games or game-like situations where security actually arises as a byproduct of rational action, right? So the idea here is that if you think about the infinitely repeated prisoner's game, then it might actually be rational to cooperate. And this sort of rationality is what keeps all parties interested in continuing the cooperation and what gives sort of the security. So if all parties behave rationally, then maybe cooperation is secure in the setting. The problem with this sort of approach to security is that and cooperation is that this is cooperation usually doesn't happen in sort of in a vacuum, right? So it's always part of a bigger system. So there are always like third parties interacting with the system, and that sort of commonly destroys the pure game theoretic nature of this particular prisoner's dilemma. On top of that, all breaks down if, for example, the interaction horizon is not infinite and so on. In principle, this second-party enforcement of security through, in the context of dilemmas is a pretty weak notion of security, of how security can arise. And so in society, we more commonly observe security as being enforced through third parties, right? So police, here you can see police, and police usually act on the basis of laws and regulations. In fact, if we look more closely at humans, then we will see that security is actually enforced through a hierarchy of different mechanisms, starting with things like mockery and mild criticism, leading to harsh criticism in front of a group, and exclusion eventually, and only in very limited cases actually direct physical violence, right? Like because physical violence is actually depleting resources from the group. So this is a reaction to sort of misbehavior. This is how security is mostly enforced actually in everyday life. So it's a sort of monitoring penalization approach. Now, the question is, are these approaches that implement security in the human realms also able to warrant security when it comes to AI agents or when it comes to electronic agents? And here are some contexts in which electronic agents or AI autonomous agents are already deployed, right? So your bidding agents, both in high frequency bidding contexts, on auctions, there are agents or there have been prize finding mechanisms that have taken part in unwanted collusion and sniper bots and so on. And of course, that's not the only context. So markets are not the only context where AI agents are interacting. But in fact, AI is also used to moderate and to shape the interaction between humans. So, for example, in automated content moderation, and there we see things like information manipulation, interference, disinformation, and so on, right? There's also, of course, the application of AI to the physical realm, so to autonomous robots and so on. And here again, we need to warrant the security of such systems. And then very interestingly as well, we are seeing increasingly virtual agents that are collaborating together. So these could be agents, for example, in the GPT store that are specialized in certain tasks, so that have maybe been trained on special data sets. And you might want to bring a software developer agent and a software designer agent. You might want to hire them, from different providers, and you might want to have them work together in a team in order to build a piece of software for you. And so when they work in a team, they also need to be able to enforce and rely on certain rules of engagement. And so this is also part of multi-agent security and what we need to solve somehow. Now, unfortunately, a lot of the work that has been done in multi-agent security so far, or generally in multi-agent learning or multi-agent systems, at least multi-agent systems of autonomous agents, and particularly advanced frontier model agents, is suffering from various vulnerabilities, that could be exploited by malicious actors. These have to do with robustness, they have to do with imperfect training, so we might not reach convergence during training, you might not solve this objective, exactly. There could be pathologies such as spurious correlation, where we're conditioning on the wrong signals. There are backdoors in neural networks that could be implanted, it could be exploited at a later stage, and might be really hard to detect. Generalization is an issue. What happens if I see unseen data at test time? Am I still going to do the right thing? Miscoordination, when we bring different agents together and they each have their own way of doing things, then they might not be able to work together. They might have misunderstandings when working jointly. And then obviously we also see dynamics, fundamental threats arising to multi-agent in the context of multi-agent security. Things like coercion, for example, where I force somebody else, one AI agent forces another AI agent to cooperate on unequal terms. Adversarial attacks, that's quite straightforward, where I'm trying to attack a system or an individual AI agent or a human AI interface. Collusion, this is unwanted cooperation between agents. Can be very hard to suppress, particularly if sharing, for example, private information that agents are not supposed to share, would help them complete a task better. There are systemic risks, so even if I know that individually my agents are nicely aligned and they interact in the way that I want them to interact to, then I still need to simulate this in a systemic context to see if there are any emergent effects that might arise that are unwanted. Data poisoning, I can just go and inject poison data into training pipelines, and then that can implant backdoors or lead to other vulnerabilities. And deception. So AI agents might decide to not be truthful about their capabilities or about their knowledge and so on, and might actually choose to deceive, or humans might use AI-driven tools to deceive other humans. And so the question is, how can we actually secure multi-agent systems in the context of multi-agent security? And there are a few approaches. So some of the traditional approaches actually here. So we can restrict the capabilities of our system, and that essentially means that we are making the system potentially more secure if we do this in the right way, but we also make it less capable, right? And so this is sort of like the last resort for us. Another approach, particularly when we want to secure cooperation between agents, it would be like to introduce some sort of trusted third party, some trusted mediator who is enforcing the rules of engagement. But the problem is that mediators, particularly AI-driven mediators, can easily get incentives to collude with either party, and it's not clear how this can be effectively prevented. So trusted mediators are certainly important, but they are maybe not the only answer in many settings. And generally, one way to enforce security in sort of autonomous multi-agent systems is through monitoring and penalization. So I try to detect unwanted or malicious behavior, and then when it occurs, I try to penalize that. And obviously, this is just reactive. The problem is, and I will talk a little bit about some research I've recently done, which shows that there are just attacks that can be fundamentally undetectable, or there might be covert communication that might be fundamentally undetectable. And obviously, monitoring also has a certain cost, and it leads to time delay. It can lead to frictions in the process. So there is a fourth way of trying to enforce and trying to weave security into multi-agent system, which is basically by design, right? So we choose particularly methods from cryptography in order to design systems that are inherently secure, where the rules of engagement are verifiably secure to all parties. And here we are traditionally in the realms of the blockchain. We'll talk about this a little bit later. Okay, so because there's so much work to be done on making multi-agent systems secure, we actually, me and a few colleagues of mine actually ran a workshop. Actually, Espen from Apart Research was one of our panelists at the workshop. You can see him here on the picture actually. So we ran this in December in Europe, and we invited the communities to submit papers, and it was super interesting. So this hackathon is heavily inspired by us asking the community about what to do in this space, right? So the tagline was the AI and cybersecurity communities urgently need to come together to create a security blueprint for our multi-agent world, right? Because historically, the security communities and the AI communities have been somewhat disconnected, and we want to change that here. Okay, here are some highlights from recent work. So some of this at the multi-agent security workshop, and some of it just generally appearing in archive. So, for example, and we also discussed this at the panel debate, right? So virtual companies. So I just talked about the GPT store and how we might want to bring agents, specialized agents from different providers together in order to jointly produce some software, for example. So people have simulated this, and so one of the questions we could ask is what are the security requirements of a virtual company? And we've already talked about the possibility of agents giving away private information that's proprietary, for example. So that's one issue, but obviously these companies can be infiltrated by third parties. So thinking about the security requirements of virtual companies now is really interesting. There are other issues, for example, once it gets to machine learning systems and preserving privacy in machine learning systems. So here we can see a paper, Privacy Side Channels and Machine Learning Systems by De Benedetti, supervised by Florent Chamet, I think, in Zurich. And we can see that actually privacy leakage can occur on multiple stages of the training process, right? And so we always need to think about the whole system and what's happening in the whole machine learning system, and not just like in individual parts of it, which is like exactly like the component of multi-agent security that we want to think about. There's of course also the option of applying AI in a national security context. So, for example, we had a submission at the multi-agent security workshop where they were looking at how LLMs would respond to certain threats, to narrate like certain stories about threats or situations where national security is under threat, and whether the LLMs would advise on options that would escalate or de-escalate conflict, right? So it's really interesting because after all, generative AI models might be used as advisors by the military in the future, or sort of like as decision support tools, but also it tells something about the inherent bias of the training data that they were trained on. So this is really interesting work, which is also application of AI systems in order to solve multi-agent problems between humans. This is also part of multi-agent security. Here's some work that I'm involved in, which is showing exactly that it is possible to have steganography that's perfectly secure. So that means information theoretically undetectable. So agents can, in principle, collude without this being detectable at all. And another work that I was involved with, illusory attacks. So these are information theoretically undetectable attacks on agents. So adversarial attacks on agents, agents might also be undetectable. So yeah, this really leads us to some of the focus points of this hackathon. And one of the focus points is going to be decentralized commitments and decentralized commitment devices, particularly secure decentralized commitment devices. I've already talked about the blockchain. So here we have things like zero knowledge proofs and smart contracts. And we really want to explore how we can use these devices in the wider context of multi-agent systems, multi-agent learning, in order to give credible commitment devices that are also secure under adversarial context. So this is one of the focus points of the hackathon. The other focus point is LLM collusion. So here's a setup, famous prisoner's problem. So it's not prisoner's dilemma, it's a prisoner's problem. It's a different thing. And here Alice and Bob are trying to establish a subliminal channel in their communications, right? Because Tom, the warden, is intercepting their communications, and so they have to maintain communications that are somewhat innocuous, but still help them transmit covert information about their prison escape plan. So they can use steganography to do that, and LLMs, and particularly, so when I say LLMs, I mean frontier models have advanced capabilities, can often make use of advanced cryptographic functions. And also they have communication channels that are natural language that have high capacity, so they might be able to, send a lot of covert information. So yeah, LLM collusion is going to be another focus of this workshop. And here you can see some reasons for why AI agents would collude. So basically, whenever an AI system or AI agents are misaligned, which can happen very easily because they might be working together in complex systems, then they might have incentives to, for example, share information that they are not supposed to share, because that can reduce the task complexity, right? So it's easier for them to complete the joint task when they share this information, but actually we don't want them to share it. And the risks, of course, then, hidden coordination and planning, that's hard to detect. And there are, of course, AI safety concerns, that could lead to catastrophic outcomes later down the line. Privacy and security breaches, exactly, you've talked about this. And then, of course, legal issues where we just violate the rules of the game, for example, market collusion and so on. So this is why this is such a really interesting. So LLMs are being used more and more in finance for trading, but also in other components of the value generation process in finance. So yeah, really important topic. And then lastly, last but not least, we are also going to focus on agent-based simulations for financial and economic security. So here's the idea that I can build simulations of humans, of companies, and so on, where instead of having hard-coded heuristics for the behavior of these entities, I can actually use LLMs, and these LLMs might be able to display much more realistic behavior under changing conditions and circumstances. And that basically means, that I might be able to simulate systems, for example, systems where there is some information feedback. I can maybe, simulate the effects of media, information spreading, and so on, and the effect on productivity and financial stability in systems, right? Like all these kinds of things are now up for grabs, it's a really, really cool new age for agent-based simulation. So we're gonna look into that. Okay, that's all for now. Thank you very much. If you have any questions, please feel to contact me. I don't have the email address on the slide, but it is cs, so Charlie Street, at robots.ox.ac.uk. All right, looking forward to seeing you all at the hackathon.